going to introduce our first speaker of the last day. So Wido is going to be talking to us about digital sovereignty and cloud federation. And as we say, do make it interactive, ask questions. So anyway, Wido, over to you. Thank you.
Thank you. Well, thank you all for attending this presentation last day, and it's great that you stayed to hear this, and I hope you've enjoyed camp and will enjoy the remainder of the day. As said, if you have any questions for me during the presentations, please feel free to ask them. I would like to be a bit, well, not a monologue, but a bit of a discussion for the presentation. So my name is Wido. I work for a Dutch cloud provider. What we've seen at our company is that the cloud usage, well, the last years has been growing exponentially, but the ones who are benefited benefiting most from it are the hyperscalers and not the European cloud providers. So this goes for us, but it goes for most, if not all, of the European cloud providers. So we have been thinking about this, and we understood that we would not be able to match the depth and the width of the offerings of the hyperscalers, and therefore we decided to do something else and team up with several other organizations to come up with a solution for that. And in this talk I would like to present our ideas on this solution, and as said, I really hope that you will well, challenge us on the things that we've came up with, and help us further developing our roadmap for the things that we are building. We wrote a proposal, and it's called Ecofed, which stands for European Cloud Services in an Open Federated Ecosystem. The proposal was written by a consortium of 5 different organizations. All of them are Dutch. 2 of them are cloud providers. One of them is a system integrator. One of them is the National Research Institute organization, and an internet exchange. This proposal or this project is part of IPSAI-SYS, which is a European program to strengthen the European cloud ecosystem. And IPSAI-SYS is, well, an abbreviation for an important project of common European interest for cloud and infrastructure services. The more info on this IPSAI-SYS program, which consists of more or less 120 projects, and we are one of them, can be found on well, 8ra.com or ORA, as they pronounce it, which is .com websites, which I think is really a pity that the European program decided to use a .com domain name. Well, as I said, we are working in our project towards federated cloud, and this might seem a bit silly to have a project working on federated cloud, since we've been doing federation on the internet since ages. So the type of services that we already run federated are, amongst others, DNS and HTTP, but as well SMTP or BGP. And somehow cloud or the cloud has taken different paths, and for the main part it led to consolidation, completely different than the rest of the internet, so which is a really pity, and we think that at least one of the reasons for that is that the description and the delivery of services have not been standardized, and that's one of the things that we are working on in our Ecofed project. Yeah. So this is what we think is the core problem with the cloud industry as it is at this moment. It is completely dominated by hyperscalers, which created or designed their services in a completely vertical stack. So they dominate and they are active on all layers, and you cannot move around within these layers to use other technologies or other providers. So it's like a single setup set across all layers of the stack. Obviously, this comes with benefits. So, for example, the ease of use is one of them. So there's one interface to control the stack that you are running at these hyperscalers, which makes it really easy to use it. But obviously, this is a single interface per hyperscaler. And another pro for this setup that hyperscalers decided to use are the integration possibilities. So it's very easy to combine services from these hyperscalers within one hyperscaler cloud. Unfortunately, there are some disadvantages to this setup as well. Well, major one is vendor lock-in. I know, especially in the Netherlands, this has been discussed a lot since more or less 6 months. This has become a very interesting and heated debate in the Netherlands, but I will not really discuss that today. Another disadvantage is that the entry barrier for newcomers in this market is very high. It is nearly impossible to set up or to start a new cloud provider the way the hyperscalers did that. This will cost you, billions of euros and lots of engineering effort. So it's nearly impossible to enter this market. And obviously, as a result, this limits the competitiveness within the market. So there's, as a result of this dominance of these hyperscalers, it's very difficult to enter this market and introduce new technologies. Well, the internet was not like that before these hyperscalers came up. It looked completely different, as you can see in this picture here. There were different providers active on the different layers in these technology stacks, and all of them ran their own, or they do run. Of course, it is not only cloud anymore yet, but they all run their own technology, and all of them can be active within a single layer of this complete stack without having the need to be active on all of these layers. And this results in freedom of choice regarding the technology that is being used. So you can mix and match different technologies within different layers of the stack, which comes, however, with some disadvantages, and one of them is, for example, the high cost for integration. So it's very difficult to introduce new technologies or new parts or new technologies because of the limited integration possibilities or the high cost, at least, of integration. And another disadvantage is that the deployment possibilities or the automated deployment possibilities are limited within this setup. However, compared to the hyperscaler setups, it does come with advantages, for example, regarding the choice of freedom, as I said, so which technology you can use, but as well the consumers or the users of these technologies, they have more power regarding, for example, negotiating about price or the SLAs, and obviously the type of technology that is being used. So what we aim for in our project is to combine the best of both worlds. We believe that this will lead to higher data center efficiency, portability, or improved portability and interoperability. So we want to keep the usability and the integration and management features of the hyperscaler clouds, and we want to keep the freedom of choice and the decoupling between these layers from the pre-cloud internet. So that's what we aim for. So the objective of our project is to create a technical basis for an interoperable, open and competitive cloud. I want to make very clear that this is a research program. So we are working on this technology. We are developing our ideas. We are discussing them with many people, organizations, companies, possible users and consumers of this technology. And this will mean, this means that you will not be able to find our technology running in the wild within a year or something like that. So it's a research program. It will take several years to develop this, to discuss what is needed with all actors, and it will take obviously a lot of effort. So as I said, we want to create a technical basis for an interoperable, open and competitive cloud. And this is an approach of the decoupling infrastructure. This is an effort to decouple the infrastructure from the platform and the application, while keeping the benefits from these monolithic hyperscalers in regards to provisioning, maintenance and integration. So when we discussed this, when we were thinking about how do we break the dominance of these hyperscalers, we had some prerequisites regarding the technology choices. So, for example, we find it very, very important that our solution is stack agnostic. So we don't want to tell you or tell providers within these layers of the stack which technology they should use. They should be able to make their own decisions on the technologies that they want to use. And we do not want to force them to change their existing infrastructure. So that's a very important prerequisite. And we do not want to oblige any providers or consumers of this federated cloud to run our software. So we will write standards and we will write example implementations, but everybody will be able to write their own implementation from this standard or this protocol and run it the way that they would like to run it. Another important prerequisite for us is that we want this solution to be future-proof. So we do not want to build a solution that's working for the internet as it is now, or the technologies that are being used in the internet as of today, but we should also be able to support technologies that are being developed tomorrow or in 8 or 12 years, at the 12th or the 13th edition of one of the Dutch hacker camps. So, for example, it's not a solution that is solely based on something like Kubernetes, for example. obviously, if you want to create new standards or new protocols and support interoperability and portability, you will need some kind of uniformity and therefore some commonality in the form of a standard or a protocol is necessary. And the last prerequisite that we had is that we want to use existing technology as far as possible, because it will take even longer and more effort if you oblige everybody who wants to join this federated cloud to start using completely new technology for which everything has to be developed. So we hook up on existing technologies and therefore we can use existing tools and software available for that for that existing technology. So we had to decide upon the functionality that is needed for this federated cloud. We had some prerequisites regarding as mentioned before, the freedom of choice for technology, portability, switchability of services, and the interoperability of it. So the functionality should at least support the declaration by users of the desired services. So, it sounds very logical, of course. Users should decide themselves what they need, and they should be able to ask for this. So this is my declaration of the type of services that I will need for the application that I want to run on the internet. Those declarations should be mapped by the possibilities that providers offer for these services. So the service offerings by the providers are mapped to the declarations stated by the users. Third functionality that is necessary is that the users should be able to provision the services themselves at the providers as seems fitting for the desired state of their application. Changes should be able to be made to the running services at these providers. Well, obviously, the transfer of services to different providers should be supported, and a user should be able to initiate that transfer. We need to have a special focus on ingress and egress, so the take-in and take-out of data. We do not want to burden users with having signed contracts and do legislative research for all parts of this federated cloud. So there should be an automated resolution of all these administrative and jurisdictional, but as well technical demands. So when we looked at what we want to support, the objective that we have, the minimum functionalities that are needed, we came up with 6 building blocks that are necessary to build this federated cloud. The first building block is what we call MPLI, multi-provider linked infrastructure, and this is part of the development within our team. So from the 5 organizations in our consortium, and MPLI is our communication standard. I will say a bit more about it later. The second building block are service ontologies, which is as well part of the development that we do, and this is a shared language that we use between both providers as users. The third building block is a compliance label, as well part of the work that we do, and this is the compliance framework. And this is necessary to make sure that we can automatically meet the jurisdictional demands, for example, from users. The fourth building block is trust. We want to use verifiable credentials for that. We do not plan to build that ourselves. There are lots of developments already going on regarding VCs. Already this is going on, but as well part of the IPSAI-SYS projects. There are several, sub-projects within IPSAI-SYS that are working on them, and one of them is, for example, Phasis. So we plan to use the work that they are doing there. The fifth building block is a service catalog, as well, something that will not be developed by us, but is part of the IPSAI-SYS and the European developments as well. And for one example, there is a DOME project that are working on service catalogs. And the sixth and final building block, obviously, is an orchestrator. You need to be able to deploy the services that you want. They are already available, and one example of that is Open Tofu. So I will get into more detail on the first three building blocks that I've just presented, the three building blocks that we are developing. The first one is MPLI. MPLI provides an API, and it runs as a standard for discovering, provisioning, and transferring services. The MPLI API matches the user requests using the service ontologies that are being created, and they deliver service declarations to the providers. This is a piece of middleware, so we need pieces of software to run on top of that or in front of it, which are the orchestrators, and to the back end, other pieces of software are necessary as well. MPLI, so this API, will not be able to support all these different types of technologies and systems and solutions that all different providers use. So we plan MPLI to steer workers or agents, and those agents should be doing the provisioning or the changes being made to the services that are being offered by the provider. So for example, if you want to run a virtual machine, or you want to start a virtual machine at a provider within this federated cloud as a consumer, you will create the service declaration or the service ontology. We'll discuss that a bit later. And the request for that virtual machine will go to MPLI, so this API, and MPLI steers the agent that will provision the virtual machine at the provider. So this means that there will be many different agents or many different workers, each one very specific for the type of stack or the type of technology that the providers are using. So a provider using, I don't know, a Proxmox infrastructure will need to run a different agent or different worker to provision a virtual machines compared to a provider running an Open Nebula hypervisor environment. This is open, obviously, and it will be possible to create your own agents that match the technology stack that you as a provider are running. So as I said, this is a piece of middleware. We will deliver the API and the worker specification, so that's part of our project. We'll create a reference implementation for this API, and we'll create reference implementations for these agents or for these workers. But as said, it is open and everybody can decide that they want to create their own agent or to create their own implementation of this API. So, well, the common API is clear, I think, and it's as well clear that this is necessary. The second building block are service ontologies, and I want to explain a bit why we think it is necessary to use them. The data and data configuration at this moment is completely siloed at providers. So they use different formats, they use different terminologies, and we do not, as said, we do not want to oblige a provider to change their technology stack to meet the demands for a federated cloud. Therefore, to federate service deliveries, we need a shared understanding of data for both humans and machines. And the last part, obviously, so it needs to be understandable by machines as well to make sure that automation there is possible. So we create a semantic layer that enables interoperability through a common or shared meaning of data. These are declarative and semantic technologies, and they both enable structure. So what is necessary, for example, to set up a VM or to create a DNS zone or whatever type of service you want to provision. So that's one, the structure of the data, and as well the meaning. So what does it mean in this? So that means that the technology is enabled to reason on the demands that a user states. So the user can declare what they need, and the service ontology makes it possible to reason on these demands and make sure that the provider will be able to match the user's request. And it will be able to infer over this data as well. This is not a new idea, so this is not something that we came up with. As I said, we are planning to build upon existing technologies, to build upon existing technologies, and ontologies are an existing standard. So we use two W3C standards there. One of them is RDF, which is data model for a graph-based data model, and the second one is Shackle, which is shaped constrained language that validates data against expected structure and rules there. Oh, there's rain here. As said, users describe their wishes in a declarative manner, and the service ontology provides a common language for service providers to describe their offerings and for consumers to describe requirements. So these ontologies are built by both users as by providers, and these need to be matched together. Third building block is the compliance label. So why do we think that a compliance label is necessary to build this federation? The label should show that the service offerings follow the characteristics of an open ecosystem. So a user should be able to know upfront that the type of service that he or she is going to acquire from a specific provider meets the demands for the federated cloud. and as a result, interoperability, switchability, and portability is possible. There's a piece of trust important there as well, and obviously this should be visible or before obtaining this service from a specific provider. So the compliance label will make sure that you can see that a particular service is comparable. So it will allow you to compare different offerings from different providers with each other. It has a predefined set of service characteristics and configuration parameters. It offers the capability to switch from one provider to another, and it provides information for automated dependency resolution. And obviously it is offered by a trusted provider. So these are the building blocks that we need. As I said, we have built three. Well, we've created three of them ourselves. Three of them will be or are being used, offered by third parties. So existing technologies or technologies that are being created within this IPSAS framework. And we are running this as it is already. So what we've done, we've moved a virtual machine, just a simple first test, from one provider to the second provider to a third provider, and each of these providers was running different technology stacks, so different hypervisors, and they were running in different networks. So this was a successful first test of our ideas. We refined this technology just a few weeks ago through the migration of containers and Postgres databases. And very important for us is as well that in such a project where you work together with different organizations, different cultures as well, different objectives, that we were able to set up a working pattern between these organizations working on this tech. We as a project are very active in the ORA or in the IPSAS environment. And this is important because we need the technologies that are being created in other projects within ORA. So it is very important for us to stay up to date, to stay connected, and make sure that the developments within these other projects are taking place, taking into account the things that we are working on. There's a question? Yeah? I think they're putting it on the mic now.
Yeah, it's working.
Yeah.
Great initiative. I'm wondering, how about security? If you offer the services, you want to make sure that the security is in place as well.
Yeah.
And that's the total of the stack makes how secure it is, right? So you should be able to monitor everything and act. How is that a part of this initiative?
Yeah, so as I said, one of the building blocks is trust, but that's obviously this is not what security is all about. We are developing supporting pieces of software, for example, to do combined logging, but I have to be clear about this as well. So it is part of, obviously, security is part of our program, but at this moment it is not the the main part of effort in our ideas or in the things that we are developing. We first want to make sure that we will be able to do what we want within this federated cloud. But you are completely right. Security is a concern and a major concern there as well. Yeah.
So I assume you can use help there.
What's that?
So I assume you can use help there.
Yeah, obviously. Yeah, for sure. Yeah. Thank you. Yeah. So as I said, we are well active in this current ecosystem. We will publish our results being part of the Linux Foundation Europe, which means that there is some type of continuity as well for this technology, even when our project will finish. We are learning lessons from what's going on within Gaia-X. Some people really like the things that are going on within Gaia-X, but there's lots of, constructive feedback for them as well, and we are trying to learn with that. And we are exploring partnerships with different organizations, for example, with people working on Dome. And what might be interesting is that the technology that we are developing is completely prepared for future EU legislation like the Data Act. And this will be a concern for others, I'm sure, about that. A question? Can this mic be turned on?
Yeah. Okay, the microphone is working. Great. Well, thanks for your talk, Wido. Very interesting. I'm very happy to see that multiple initiatives are working towards digital sovereignty, because I'm from the Coalition for Fair Digital Education, and we have a similar project also working on digital sovereignty, but then focused upon schools, mainly in the Netherlands, but also international. But I also had a question, because I heard it's a lot of research project, but I did not see any research institutions mentioned that are involved.
Yeah.
Are they involved, or are you working to get contacts with them? Or?
No. So our consortium consists of 5 partners, 2 of them cloud providers, 1 system integrator, 1 internet exchange, and the National Research Institute of the Netherlands. So TNO is involved. Yeah, I didn't want to call out names here, but
Okay, are you also looking for universities? To get involved in this?
Not specific. Well, I will come to that. That we would love to have more people working on this, and obviously universities are one of them as well. But the core team of the project consists of these five organizations.
Okay, it makes sense to have a small core team so that you don't spend endless days having meetings.
And boarding people, and then
Yeah, okay. I don't see a queue behind me, so can I do another question?
You can. I will finish, and then we'll have. But please, I'm done in 30 seconds with things that I wanted to say. I wanted to ask you, again, for feedback on the ideas that we presented. I want to ask you, whether you are interested in participating in this project. That can be done in a user panel. If you're interested to ride along in the ontologies or the orchestrators or whatever, please do reach out. And there's one thing that I wanted to say as well, because we've been, especially in the Netherlands, there's been a lot of discussion on digital sovereignty, and this discussion mainly took off 6 months ago, or maybe a bit longer. I think had something to do with somebody in the US being elected. And if you, as an organization or company or whatever, if you really want to support the European cloud, so things that we do are well, I think are helping, but what would be very helpful as well is if European organizations start buying European products. So please buy your services at European organizations. This is the last slide. You can scan the QR code to get a copy of the presentation. And, well, there was room for questions, but there's room, I think, 5 minutes for more questions. Yeah, Olaf, please.
Hi, Michiel Leenaars from the Netherlands Foundation. So, who runs the who runs the middleware? Because in a federated system, normally there is not a party running the middleware.
Yeah.
You negotiate, but it's.
So this MPLI middleware, that's what you mean, right? That's run by each provider. So they run, all of them run this API, and the orchestrator should connect to all these different API endpoints at the different providers where they want to obtain services or change services or whatever. So this is not a centralized solution, if that's what your question is.
And yeah, then of course, who does the billing on behalf?
Your question is who does the billing on behalf?
Billing.
Oh, billing. Billing. Yeah, good question as well. We have not decided upon this yet. As I said, we want to do automatic resolution of SLA demands and legal demands and stuff like that. And billing is, well, related to that. And we are discussing, okay, should this be, I don't know, should we allow or make it possible for a consumer to have a single contract? Well, no, that's what we decided. But should we allow and make it possible to have a single invoice coming from one of these organizations on behalf of all other providers offering services within that as well? But we have not decided upon this yet. Yeah, but it's a very good question. Thank you. Yeah.
Yeah. Question in the queue, and then we have one in the audience, and then we will see with time.
Yeah.
Thank you. There are actually a lot of isolated initiatives for nearly everything you need, but not the unified. There's a sovereign cloud stack, you have encrypted file systems, you have certificate exchange automatically, you have even confidential computing, which is not quite major at the moment, to solve encryption in memory. Not major at the moment. And you have this European Cloud to Edge initiative, where all seems to address more or less problems with a big overlap. And do you see some coordination that you can collect from all these projects the best and united, that we get something real in 2 years or something like this? Not only concepts, but real working clouds? Yeah, well, good question. Two things I want and I can say about this. I did not make that clear, but as I said, for us this is a research project, but there's an obligation as well to finalize it with the first industrial deployment. So we do have to create technology that will be used in a production environment. So that's a prerequisite there. And you are right that there are lots of initiatives for this European cloud. Most, but not all of them, are a part of this IPSAI-SIS project, which are 120 different projects, all building, creating parts of the puzzle for this. And the European Commission is responsible for, keeping them connected, but it's a European project and it comes with European problems as well, let's say. Yeah, and one of the dangers is if you involve academia, they are simply hired after in the mid of the project. This happened to me
and went to Facebook for more money. So I would make it in such a way that it is not relying on academia. Academia is too weak to contribute to real solutions at the moment in Europe.
Yeah, yeah. Okay, thank you.
Am I on? Yes. How does this compare to NeoNefus? I think it looks almost the same initiative, also IPSA-ISIS, and also by TNO. So
I'm sorry.
NeoNefus? Do you know? You don't know it?
Oh, NeoNefus. Yeah.
I'm confused about it. So
no, I can understand. NeoNefus is a project by SAP actually, and they are working mainly on containers. So that's where their biggest focus point is. It is compatible with the things that we are doing, so it will be possible to run NeoNefus technology in combination with the things that we are building. But you are right, there is some overlap in, well, at least in the objectives of the solution. Yeah. Okay. Thank you very much.
Thank you, Wido, for a really interesting talk. It makes me actually think about, comparing to, I don't know, in different parts of society, we've got the change from going to the high street to who shops in a supermarket. And realistically, a lot of us do, don't we? Because it's very convenient. Yeah. And I wonder if it's like the digital example of that. And it's quite hard to compete with that, isn't it? Just the convenience.
Yeah, you're right.
But no, it's a brilliant project. Thank you for telling us about it.
Great.
So, yeah, thank you.